We're given the robot's initial mortality rates and annual improvement factors. We want to calculate the probability that the robot placed into service at time 0 is still functioning at the end of 3 years. Okay, so the robot starts at age X, and it has to survive 3 years. So it has to survive X plus 1 and X plus 2 as well. So the first number represents the age, and the second number represents the improvement factor. So in the first here, P of x0, the improvement factor is 0, so that means we're not going to use an improvement factor, so we'll just have it as 1 minus Q of x0. For P of x plus 1, comma 1, that's just 1 minus Q of x plus 1, comma 0. And then here we're going to have an improvement factor, so it'll be 1 minus phi of x plus 1. And for P of x plus 2, comma 2, that's just going to be 1 minus Q of x plus 2, comma 0. And then the improvement factor is 2 here, so it'll be 1 minus phi of x plus 2, quantity squared. So now we can just use the table, Q of x0 times 0. So here, x is going to be 0. That's going to be 0.4. So that's, in other words, 0.6. So Q of x plus 1, that's Q of 1, 0, which is 0.5. And then we're going to multiply that by 1 minus our improvement factor at time x equals 1, which is 0.15. And then finally, we have 1 minus Q of x plus 2, 0. So that's just, in other words, Q of 2, comma 0, which is 0.6. And then the improvement factor is 1 minus 0.2 quantity squared. So we'll go another step here and simplify these. So this one is 0.575, and this is 0.616. So in order to see when the probability that the robot survives, or the robot is still functioning at the end of 3 years, that's the same thing as multiplying these three probabilities. So that's 0.6 times 0.575, and then times 0.616. So our final answer is 0.21252.